14, the Atmosphere, Air Quality, and Pollution Control from the Essential Environment textbook. This chapter is talking about clean air and emissions and pollutants and different things and laws that have been passed in order to keep our air quality clean. So it starts off talking about clean air in Los Angeles and in Mexico City and how those two areas have dealt with pollution. And it's something interesting to look at. So I have a couple videos that I highly recommend on this topic that kind of just show you a brief overview of what the cities looked like in the past and some changes that they've made to working towards cleaner air. So the first one is Mexico City's pollution towards cities pollution, and then it's called Toward a Better Future. So I recommend checking out that one that shows what the air looked like, like 30 years ago versus now, and why it gets so dirty. It's because they have a very large population there, but what they've done to make improvements. This second video is a breath of fresh air from Mexico City, and it's about the vertical gardens in Mexico City. So they've started planting throughout the city, up like the columns that hold the freeways or overpasses. They have planted a lot of vertical gardens to help reduce pollution. It's really pretty, actually. And then the last one is called Blue Skies and Clean Air, Los Angeles After Coronavirus, and it's from CBS this morning. And that kind of goes through when Los Angeles was shut down, how the air changed. So one of the ways that air pollution has been reduced is that in 1975, catalytic converters on cars became a required, like, necessary piece of the car. And these catalytic converters, specifically, what they do is when your fuel is combusted inside of the engine, in theory, it should come out as somewhat non-major pollutants like carbon dioxide, water, and nitrogen. However, there's an incomplete reaction that ends up going on, and the reaction doesn't happen completely. So the catalytic converters have different metals inside, like platinum, palladium, and rhodium, and they are surrounded by a ceramic core that gets really hot, and those metals, or the metals that are inside at that heat, are a catalyst, like start a reaction to make sure that the combustion of the fuel coming through is complete. So it takes these higher pollutants and makes them into things that won't destroy the ozone as much, because those what comes out, which is carbon, the incomplete reaction causes carbon monoxide, nitrogen oxide, there's some unburned fuel, and all of those things react with ozone to break it down. So essentially, we don't have the ozone to protect us. So that's how catalytic converters work. There's a whole video here that I would recommend from Donut Garage. They have the video on how do catalytic converters work, and it's helpful to understand how that is working. So the average driver is in traffic for about 3 hours a day, and as people are doing more work from home, like during the pandemic shutdown, traffic dropped by about 60%. So the more that we can get people out of traffic, not only could they enjoy their lives a little bit more and not have so much wasted productivity time, but it also helps the air. So the atmosphere specifically, what it does for us is it moderates our climate, it gives us clean oxygen, it shields us from radiation, and it helps us to cycle nutrients. So there is this video that I recommend you watch called Climate 101 Ozone Depletion from National Geographic. And it talks about how ozone is basically the Earth's sunscreen, and it helps absorb radiation. It's in the stratosphere. It's very, very reactive, which is why it helps absorb radiation. But it is a very trace gas. There's very little of it. There's only about 3 particles out of every 10 million particles in the stratosphere are ozone. So we have very, very little ozone, and we need what we've got. So the atmosphere is mostly nitrogen and oxygen with smaller amounts of other gases. And the troposphere is the bottom layer of the air that we breathe. The stratosphere basically warms up with altitude, and it actually has the majority of the ozone layer is here. This purple is the ozone layer in the stratosphere. So our sun obviously changes our weather and climate and makes different convection like currents, like air currents that rise and fall. We see different convection currents at different layers. So weather specifically is whatever the conditions are locally over a short period of time. So when we're talking about weather, we're talking about weeks or like what it is currently at the moment, whereas climate is the long-term patterns for a certain location over long periods of time, like years. So normal air movement is that as air rises, the warm air will tend to rise, and as it rises, it actually cools down and spreads out. That rising will actually take a lot of pollutants off of the ground, like the air closest to the ground that we're breathing. It will actually remove a lot of those pollutants and push them upwards for us. However, sometimes you'll have what's called an inversion, where you'll have a high pressure zone here that keeps the warmer air right next to the ground, and that can keep a lot of pollutants near the people. This is a good video on a inversion and what it is from the National Weather Service of Reno, and it's called What is Inversion? So I recommend looking at that for a little more information. Near the equator, there is what's called convective currents called Hadley cells, and they basically will cause a rapid rise and fall of the air there, the warm, wet air, which helps create some like stormier, wetter weather for like our tropical zones. Then there's feral and polar cells that are 60 and 30 degrees north and south. And then there is the Coriolis effect. Let me see if I can go back to, let me see. Oh, here's a good picture on that. The Coriolis effect causes the water in the or currents in the northern hemisphere to move in one direction, but in the opposite direction for the southern hemisphere. And then the doldrums lie at near the equator. This is where both sets of air masses are moving in opposite direction, and you get this kind of dead zone where you don't have much movement of currents and air. And then the trade winds, which were used to trade because they would move the boats really quickly, blow from east to west between the equators. The westerlies blow from west to east. Okay, so pollutants that are in the air can be all kinds of different things. It can be different chemicals that are emitted. It can also come from natural things like volcanoes or fires, and humans can contribute to this bad air, absolutely. That's saying like volcanic eruptions can even release a lot of different pollutants into the air that we essentially need to deal with. We can also have things like large dust storms that will blow pollutants that aren't good for us to breathe in. So primary pollutants are ones that come from a direct source, like you could say, come directly out of a car, or it says here like a power plant or a volcano. And then primary pollutants can also react with secondary pollutants that are just like general pollutants from a whole area because a group of, for instance, people are living there. The amount of time a pollutant spends in the air is called its residence time. There's some pollutants that will not stay in the air for very long, and you deal with those more locally. And then there's some pollutants that will stay in the air for a very long time. They're very slow to break down. And because of that, they end up being spread through the air on a global level where everyone has to deal with those pollutants, even if they weren't the general area where they came from. In 1963, the United States passed the Clean Air Act, which helped monitor emissions from things like cars, factories, and other like point sources. So, different organizations monitor these emissions, and here's some different pollutants. I have a few slides on that and where they're from, and then why they're bad. So, for instance, sulfur dioxide comes from coal, the combustion of coal for electricity, and it makes acid rain, acid precipitation. Carbon monoxide, it's mostly from vehicles and engines, and basically it can combine with our hemoglobin, stopping us from being able to carry oxygen to our cells. And that's a bad thing. If we can't carry oxygen to our cells, you can quickly have a lot of problems, if not death. Nitrogen oxides, they have an N, O, and then an X because this can come with different amounts of oxygens attached. But basically, this is also engine combustion. It makes acid rain, smog, and depletes the ozone. Then there's volatile organic compounds. So this is by different engines and solvents and can make smog. So there's other particulate matter like different dusts and things that we have, and lead, which we can get from burning gasoline, from different metal work like smelting. And it's bad because it's a toxin that permanently accumulates in our body and can cause nervous system dysfunction. However, there is some good news. We have reduced emissions since the 1970s with the Clean Air Act. So look at these different types of pollutants. These have seen a huge decrease because these were started to be regulated in the 1970s. These pollutants have gone down, but they were not regulated till 2002, so they haven't seen as big of a decline, but they also haven't had as much time. There's different technologies like scrubbers that can basically run pollutants through a machine that sprays water, and it basically gets the water to, and usually this is like warm water, it will actually get it to combine and cause an acid rain inside of the machine so that that acid rain can be collected inside of a machine instead of raining out. So we already talked about catalytic converters. We talked about why leaded gas is so bad and why it needed to be phased out. So the EPA monitors 6 different pollutants in what's called the ambient air quality standard. There is more than 4,000 of these stations that basically are taking air samples constantly throughout the day, usually hourly. And we have seen, this is a chart showing how many days of bad air there were in each of these cities since like unhealthy air since 1980. So you can see that all or most cities had a steady good decline by having various emissions laws. Locally in Southern California, San Diego is down to about 20 polluted days of air that we're breathing in a day. However, Los Angeles is still at 106, so still has made a lot of progress, but has a long way to go. This is a cool website called Cool Climate Maps that I recommend checking out. So smog in particular is a mix of air pollutants that basically combines with the air and makes a cloud over you. Specifically, it makes a fog of pollutants that stays over your area and you breathe it in. Smog was first really documented and seen maybe like 60, 70 years ago, but in 1948, Pennsylvania had a bad episode of this that did kill some people. However, London had a killer smog in 1952. It was 4 days of a high pressure inversion. I recommend this video called 5th of December 1952, The Great Smog of London Begins, and it's from History Pod. But it talks about how just during those 4 days, they saw between 4,000 and 12,000 people die. That's a huge range of people. I think they just didn't know how to document how many people were dying because the air quality was so bad. But as low as 4,000 in 4 days and as high as 12,000 in 4 days died from this. That's a lot of people. So this can be made worse with being exposed to the sun. Good news is that because of stricter emissions laws, cleaning up our gasoline, having things like catalytic converters on cars, even though Los Angeles drivers are driving 2.7 times more than they were in the 80s, they have still substantially decreased their emissions, which is awesome. They're driving a lot more, significantly more, but emitting a lot less pollutants. So eventually the federal standard for emissions would be here. We're getting there. We're not there yet, but it's definitely declining and getting better as we move along. So there are some countries that are worse with their emissions. 17 of the 25 most polluted cities on the earth are specifically in India. That's really unhealthy for the people there, and over time I would hope their government encourages them to have stronger emissions laws. There's different laws in the United States that have regulated different pollutants. So specifically, the ozone is something that is in flux. It's not something that we've lost it and we cannot get it back. The ozone is currently slowly but steadily recovering from the damages that were done. There's certain substances that deplete ozone and it's very reactive. So when different substances want to react with it, it's totally willing and then it gets broken down. Specifically halocarbons, which come a lot of times from refrigerants, things that are used in air conditioning, fire extinguishers, spray cans, they or like cleaners for electronics. They will often have halocarbons or chlorofluorocarbons, which really stay in the atmosphere for a long time and have a hard time breaking down, and combine with ozone so that the ozone no longer exists in the form that we need it to help us with the radiation coming in from the sun. So this is a diagram that helps explain that, but we want to make sure that we are limiting our use of that. So the ozone hole gets worse every spring and summer. It grows really large over Antarctica. And then in the fall and winter, when things cool down, this ozone hole will shrink up a little bit. However, it has not totally been closed for a long time. It's hoped that the ozone hole will close completely by 2060 if different countries keep participating in processes that will close that. So different acid rains. The way that acid rain happens is we get these different pollutants in the air. When they go up into the air, they can combine with water, with basically water and oxygen, and they can basically come down and be part of that rain and drop as an acid rain. So you can have sulfuric acid or nitric acid, and maybe just in really low acidic rain dosages, but when it hasn't rained in an area for a while and that rain comes down, it is slightly acidic. And that is what acid rain does. You maybe don't notice the effects, but when they do things like this, where this was like an Egyptian building, and you can see here that as it was moved to an area of where it was exposed to a lot of acid rain, it eroded really, really quickly. So in 1990, there was different Clean Air Acts passed, and basically these laws started to produce or started to lay the foundations for what is called cap and trade, where different companies were given permits um, to have so much emissions or so many pollutants from, say, a factory. And so that company, then, if they go and make healthier choices or invested in things that would reduce their pollution, they could take their permits and sell them to another company that was polluting too much. And so they made money off of the sale of their permits, and they also reduced their emissions. Then the companies that were the larger producers of pollutants, they were having to pay for those extra permits from the greener types of companies. And so that maybe incentivizes them to try to look for technologies that would lower their own emissions. So that was called the cap and trade system. It basically set it up so that among different companies, you could decide for yourself, are we going to pollute more and have to buy these permits, or are we going to take that same money and invest it towards greener technologies? So that's basically how cap and trade works. It's been highly debated, but it has shown or pushed a lot of companies to make greener choices with their technology. In developing countries, and some that I have lived with, sometimes people don't think about as much, or they're not able to even worry about the air quality there. And so you do see some practices like cooking in open fires, but inside, where we wouldn't really ever do that in the United States because of how bad the air would be. But you do see it there, or like animal waste being used as fuel and then people breathing that on the inside. I do see in other countries a lot of like smoking that can cause lung cancer and be really unhealthy even for the people that are not smoking. Inside our own homes here, especially in the United States, there's tons of pollutants. It's really healthy to open your windows and let in fresh air as much as possible and not just keep the same air inside, because there's all kinds of different things that can pollute the air just inside your house. So in where we live, things that you could reduce, like easily reduce some air like emissions and pollutants, is making sure that you have dry wood or cooking outdoors, having less polluting fuels such as natural gas, and then opening windows, like increasing ventilation. So that is our entire lesson for chapter 13, the atmosphere, air quality, and pollution control.